Hello. So today I'm going to talk about the water level sensor. This is the reflex glass, and in the back of the reflex glass, at a little over halfway up, there is a port. And in that port goes this sensor. It comes in and sits like so. And the idea is that the water moving over that, either going up or coming down, will cause a change in a signal. And that's because embedded in this sensor is an infrared emitter and an infrared detector. And the presence of the water changes the way that the signal is read. Now, Steam Traction World gives you a box with electronics in it. I've taken the electronics out. And the electronics consisted of a 5-volt converter to take 12 volts to 5, and then a sensor board for the sensor that reads the change, and then a relay board that, when it sees a change, will either engage the relay or release the relay. And when it sees water, then the relay is engaged, and it allows the voltage to continue on to the pressure sensor, which allows for the burner to be fired. If it sees the water level drop below the the sensor position, then it releases the relay, and that would then turn around and cause the burner to stop. The idea being then that you would turn the manual pump bypass to engage, so that the water is forced into the boiler as you steam along. I decided to change and do some things. One is I wanted to add a valve. This is an electric valve that is going to be placed with appropriate adapters into the line behind the manual bypass, so that the manual bypasses first, and you could manually engage it and force the water up, or this can be engaged, and if this valve closes, then the water is forced into the boiler. So I wanted to be able to have that be automatic. To do so, I also wanted to make sure that it wouldn't just sit there and cycle on and off, because if I pumped water in and it changed the water level in the sight glass, it would sit there and go on, off, on, off, on, off. So what I wanted to do was to take my sensor, and when the water dropped below, have it turn off the boiler and engage the valve to pump in. And then I wanted it to pump for a period of time to fill the boiler back up again past the point in which the burner would be re-engaged. I also wanted to keep the burner from cycling. If you know about the way this works, the burner is fired by a 12 volt to 220 volt inverter, which causes the burner to go on. And I didn't want to sit there and have it cycle. So I wanted a little bit of protection. To do that, I came up with my version of the water level sensor. Now, inside we have the previous provided by the electronics that's provided by Steam Traction World. Here's the voltage regulator, here's the relay board, and here is the sensor board. So the sensor's attached here. When it sees it changes, it takes that and sends it to the relay, and the relay engages, which turns around and basically engages and takes the 12 volts and routes it off to go back out. So what I did was I added two things. First of all, on the normally closed section of the relay, I had a relay card added. So basically that would trigger the relay. And that's because directly next to it is what's called a retriggerable card. And what this does is when it sees a contact closure, it triggers the relay for a period of time. And you can vary the amount of time. It gives you a reading here, so of up to 99 minutes. In this case, I set it originally to 2. And so the idea being that when the water level drops down, the burner turns off, which releases the relay, which engages this relay, which causes a contact closure to the retriggerable board, which closes this relay and starts a counter for 2 minutes. And that turns around and turns and closes the valve. So when you continue to drive for 2 minutes, it'll be pumping it up. Then, and I will show this operating in a test mode in my next video. When the water level comes back up, this unit will continue to pump. And if the water level drops back down again, it actually will re-trigger this to start over at 2 minutes again. And it'll just keep doing that. And now when I did that, I found initially that the water passing by the sensor could cause this to flutter. And that would cause this relay to trigger multiple times. And I didn't want to have that stuttering. So I put in a debounce circuit. So what I did was I took an Arduino and I wrote a little program that says, watch this pin, and if you see that pin stabilize for 1 second, then go ahead and send and then engage and send the sensor information to the relay card. And if you see it change and it's stable for another second, change it back again. And this is a little voltage regulator which takes the garbage voltage from the incoming from the batteries and cleans it up a little bit and reduces it so that the 5-volt Arduino card's a little happier and just keeps that from happening. Anyway, that's the circuit, and I will demonstrate that on the next